Hi, and welcome to my tutorial. In this video, I'm going to show you how to set up SQLAlchemy together with Alembic so that you can manage changes to your database from your code. First of all, if you're not familiar with SQLAlchemy and Alembic, let me introduce them to you. SQLAlchemy is an object relational mapper, or ORM. It means it's a library that offers you an object interface to the data in your database. This has two major advantages. First of all, ORMs give you a layer of abstraction over the database. It means you don't have to write SQL code directly to perform transactions with the database. ORMs typically also abstract out the specific differences between different SQL engines. So whether you're working with PostgreSQL or MySQL or even SQLite, you won't have to change your code if you're using an ORM. The second biggest advantage of ORMs is that they offer you this object-oriented interface to the data. This object interface is based on classes that you define in your code, and this gives you the possibility of leveraging the benefits of object-oriented programming to enrich those classes with additional properties and methods that can make it easier to work with your data. Now that's SQLAlchemy. What is Alembic? Alembic is a different library, but it's very related to SQLAlchemy. It's part of the SQLAlchemy project. Alembic allows you to replicate in the database the schemas of the data that you have defined in your code with SQLAlchemy models. If we didn't have Alembic, we would have to create the tables with the columns and these data types manually in the database. There is ample room for error when we do this manually. Alembic ensures that the schemas in our database are an accurate reflection of the models that we define in our code. Now, in this video, I'm going to show you how to set up these two libraries together. When working with different teams, I've often seen that people have sometimes confusion about how to set up Alembic correctly. So in this video, I'm going to show you how to do it. Another question you may have is, in which situations do you use SQLAlchemy and Alembic? And the answer to this is whenever you have to interact with a SQL database. Perhaps with the exception of Django. If you're working with Django, you may already know Django ships with its own ORM library. And because it's already built into the Django framework, you don't have to look any further to create your ORM models and to manage your migrations. But if you're working with Flask or FastAPI or Starlet or any other web framework for Python, or even if your project doesn't have anything to do with a website, other kinds of applications also need access to a database, and often this is a SQL database. So here is where SQLAlchemy is going to be very useful. Now that's enough of an introduction. Let's get started with the code. Alright, so I'm going to start by creating a folder for this tutorial. I'm going to name the folder Alembic SQLAlchemy tutorial, and I'm going to cd into this folder. Next thing I'm going to do is to create a virtual environment. Virtual environments are always recommended in Python because with virtual environments you can make sure that the dependencies that you're using in a specific project remain specific to that project, which means you avoid having conflicts with your system dependencies. Now I'm going to use pipenv to manage my virtual environment, but you can use any other tool that you want. I'm going to use also Python 3.9, but again you can use any other version of Python that you prefer to use. Alright, so the virtual environment is created. Now let's activate it by running pipenv shell. So that's our virtual environment activated. Now let's install the dependencies that we're going to use in this tutorial, which are Alembic and SQLAlchemy. Alright, so our dependencies are installed. If you're not familiar with pipenv, this is what it looks like. When you run pipenv and create an environment, it creates a file called pipfile. This file contains a description of the environment. It lists the dependencies that you're using in the project, and also represents the version of Python which is required to work on the project. In this case, it's just picking up the version of Python that I used to create the virtual environment. Right, now let's set up Alembic to manage the migrations for this project. The first thing we need to do is run Alembic init migrations. So this command creates a folder called migrations, and it also creates a configuration file for Alembic called alembic.init. We're going to look into that file in a minute. Let's look into the migrations folder. So within the migrations folder, we have a README file, which explains how we work with Alembic. It contains also an env.py file, which is a file that defines configuration for Alembic that Alembic needs to use when running migrations. It also contains a folder called versions, which is where our migration files are going to be stored. Now, the next thing we want to do is edit the Alembic.ini file and configure it to point to a specific database. I'm going to use now to edit the file, but you can use any other text editor which you like. So if we look for a variable called alembic.url, here we can put the URL of our database. To keep things simple in this tutorial, I'm just going to use SQLite. So it's going to be SQLite models.db. We save the file, exit, and the next thing we're going to do is to edit the env.py file. Let's open this file in the text editor so that you can see more clearly what's going on in that file. So this file contains a couple of commands, which are the commands that actually run the migrations in your database. And there are a couple of important lines here. It's these two lines around here. We need to replace these lines with something that points to our database models. We haven't implemented those models yet, but we're going to do that in a minute. So let's go ahead and change these lines right now. What we're going to do is from models, import base, and target metadata is going to be base.metadata. So those are the changes that we need to make. We're going to create this base class in a minute in the models.py file. So this is all the configurations you need to have in place to set up Alembic to work with your SQLAlchemy models. Now let's create one SQLAlchemy model here so that we can run an actual migration and work with the model and the database. So the first thing we're going to do is to create this base class. And we're going to use Alembic's declarative base function to create the base, to create this base class. Declarative base. Now we can import this directly from Alembic. Now, what is this base class? This basically is Alembic's base ORM class. All of our models have to inherit from this class, and by doing that, Alembic is able to look into the properties of our classes and map them to specific table columns in our database. Now, let's define a simple class. Let's say a user class with a few properties, just for illustration purposes. So we're going to call it user model. It inherits from the base class, like I said before, and it's going to have a few simple properties. It's going to have an ID, which is going to be a column. It's going to be, let's say, an integer, and it's going to be a primary key. Now let's import these classes as well. This is SQLAlchemy's column, and this is SQLAlchemy's integer type. We're going to have also, let's say, a first name, which is going to be another column. It's going to be a string, and it's not going to be nullable. That's going to have also a last name. It's going to be another column, string column, and also it's going to be non-nullable. Let's add also a property to say when the person was born, and that is going to be a column with a date time, and that, let's say, that one can be nullable, so we don't need to do anything else. And finally, let's add a created field, which is when the record was created, and that is going to be a column with a date time, and it's going to be have a default value, which is date time UTC now. We need to import date time from Python, but not like that. We need to import the datetime class. All right. Another important thing we need to do with SQLAlchemy, we have to tell the model what's the name of the table that we want to map the model to. So that is going to be with this property here, table name, and that is going to be user. It's going to be a user table. All right. So this is all we need to do to create a SQLAlchemy model, a simple one. And we've already configured SQLAlchemy to point to our local SQLite database. And we also configured in the env.py file, we configure Alembic to look at our base class. So that import statement here doesn't complain anymore. Now let's go to the terminal and run the migrations. So the first thing we need to do is to create the migration file, and we do that with this command: Alembic revision auto generate, and we give it a name. It's going to be create user model, and there you go, a migration has been created. Now this is here under the versions folder, and you can look into the statements that SQLAlchemy is generating to populate the table, the database with this user table. Furthermore, if you were interested, you can render these SQLAlchemy operations into actual SQL statements to see what it would look like, the commands that Alembic is going to run against the database. So the migration is now ready. Now we need to apply the migration to the database, and we do that with this command: Alembic heads, Alembic upgrade heads. And there you go, the migration has been applied. If we list the contents of the folder now, we see one new file, which is models.db, which is our local SQLite database. Now we are ready to start interacting with the database. So let's write some code within the same models file that we defined earlier. And let's write some code here to save a couple of records into the database. So let's define a list of users. And the first of them, let's say first name is Bob, last name is Preston, and the birth is date time 1980 May the 2nd, for example. And let's define another user model that is going to be first name, let's say Susan, last name is going to be Sage, the date of birth is going to be 1989, 6 and 12. Okay, now to interact with the database using SQLAlchemy, the first thing we need to do is to connect to the database and to create a session. Let me show you how we do that. The first thing we need is a session maker. So to create a session maker, we use the session maker function of SQLAlchemy. We import this function, and what we need to give it is the result of calling create engine together with the database connection string. And that is SQLite models B. Let's import this function as well. Alright, so we have the session maker. Now to create our users, let's create a function that does that. So create users, and to use the session maker is actually a context manager. Basically what we do is we create a new session every time we want to interact with the database. You should do it this way, because if you do something like keeping a persistent session across different transactions, what can happen is you may have two threads writing to the database at the same time using the same session. If one of the threads makes something wrong and has to be rolled, and the transaction has to be rolled back, this is going to affect the same other thread that is running a transaction in a different context. You don't really want to be in that situation. You can also end up with a corrupted session in your application. So what we do is using it as what it is, which is a context manager, and we say with session maker as session, we say for user in users, session add user, and then we say session commit. Now we run this function, create users. Oh, that was a typo, it should be users. And we run this code, and we've created now those records in the database. You can't see that yet, but we're going to see it very soon. Now what we do to query these information, to query these records, is use the session maker again to create another session as a context manager. And we say user records is session query user model all. And then for user in user records, we're going to print each user. And let's see what happens. Right, we've got two uses from the database. Now, this representation of every object is not really very useful. So here's where the power of this object interface to the database is gonna be helpful. What we can do here to make things easier is to define a representation method, which is the method which is called on the class when we want to print it. And what we can do here is to create a more readable representation of each object when we want to print it out. So what we're going to do is to provide all the details about the user when we print the object. So we say user model, the ID is self ID, and first name equals self first name, and last name equals self last name, and birth equals self birth, and created equals self created. Okay, so this is a simple way of representing the data. You could choose any other way of representing your data. This is just a good snapshot of what the record looks like. Obviously, if the record was a lot bigger with a lot more properties, and if some of these properties were large chunks of text, you wouldn't want to include everything. Maybe you want to trim down some of those properties, or you want to just include a small selection of them. But in this case, we can afford representing all the properties. So let's go ahead and run the code again and see what this looks like. And this is now so much more readable. We can see what each object looks like. Now, a more obvious way of leveraging the object interface here is, for example, by adding a property here that says, for example, full name. So we create a property here, we call it full name, and what it does is returns, let's make it like this, first name and last name, like that. And what we can do here is print full name for each user, and we run the code again. What we see is it's printing the full name of every user in the database. We could create additional methods here. We could create a method that tells us whether the user is an adult or not based on the date of birth, or additional methods could be especially useful when you're working with large amounts of data. We could have additional methods here that allow us to transform the data, to pivot certain tables, or to do certain transformations before we serve the data to the business layer of our code. So there you have it. That's all there is to working with SQLAlchemy and Alembic. I hope you enjoyed this video. If you did, please like the video. Feel free to share it with your colleagues or in your network. Feel free to leave a comment on the video. And if you're interested in the work that I do, I'm also the author of microservice APIs with examples in Python. So it's a book fully dedicated to explaining how you design and build microservices, how you drive their integrations through APIs. I provide specific examples for how to build REST APIs and GraphQL APIs. It also explains how to add authentication to your APIs, how to deploy your microservices with Kubernetes, and it dives deeper into the topics that I covered in this video, including SQLAlchemy and Alembic. So that's everything I wanted to say. Thank you for watching this video, and see you soon.